First up, we have talk about the SciPy Proceedings stack, an exemplar for publishing computational open science from Franklin, who I think is representing Rowan, who was the original author on that doc.
Yeah.
It's a team effort.
Yeah. So I work with Rowan. I worked with Rowan forever, and he couldn't make it this time, so I'm here. Cool. So I'm talking about the SciPy Proceedings. I'm going to introduce the proceedings a little bit, and then talk about all the work that Curvenote did to kind of try and level them up, and then talk a little bit about looking into the future. But I feel like the first thing that's probably worth talking about is like this whole thing here. So like I work for Curvenote, which is a sponsor because we do the proceedings. I'm also on the SciPy Proceedings as a committee member, and I'm also a core contributor to the open source Jupyter Book 2 MyST project that it's all built on. And so like I don't know if we should panic about this like seeming conflict, but like I don't know. It's if you want to, you can. But I just want to celebrate it all, and I'm happy to be part of all of these different things. Cool. And I think that's the whole theme of all these talks is supposed to be celebrating. So cool. So the SciPy Proceedings. If you haven't heard of them at all, anyone who is accepted to give a talk or a poster at SciPy is given the opportunity to also write a paper that they can then get reviewed and get published and get a DOI with SciPy. They were started in 2008, which was the 7th SciPy conference. And this is great. It's such a area of like annoyance, I think, when people are like, oh, how do I publish my code? If you like Google, like, where do I publish my code that I made as a grad student that's awesome? You get these like really toxic Reddit threads that are like, just don't do that, just whatever. But it like doesn't make any sense. And so there's there's journals like JOS, which are also like great and leading the charge on this kind of thing. But JOS was started, I think, in 2016, and so SciPy was allowing researchers to get their science and their code out almost a decade before that. And so that's just great. It's a really good thing. It's always been a good thing to enable this community to publish in a way that maybe other journals have a harder time with. It's always had an open submission and review process, so it's been through GitHub. The reviews are on GitHub as well. That's how it's always been since the beginning. And in its history, there have been about 350 published articles, and everything is available and archived on scipy.org, totally open and available for anyone. That's all really good. You can check out all of the history, the historical abstracts at proceedings.scipy.org. Nice. So there's still a disconnect, the PDF problem, I guess. So like this is forgetting about SciPy and the cool Python sciencey stuff. Like this is bad enough that we're still like looking at PDFs on phones. And I mean, this is like a kind of silly caricature, but I feel like you can relate in however that makes you feel, seeing this thing on your phone. And so like if you think about how we have it even worse at SciPy, we have interactive widgets and 3D visualization and code that like actually works and dynamic links to software docs. And like if you think about all of those as little bits on here, like it's just pretty bad. And so this is a PDF publication that was how. So this is a SciPy Proceedings article from early on, from the first year actually. And so it's great that we can publish this, but it's still in the PDF. But people are bringing things like this to SciPy and showing off amazing work in amazing ways. Cool. So then last year, Curvenote, my company, got involved with Proceedings, and that also got MyST involved because all of the Curvenote work is built on the open source tooling of MyST. And if I can talk more about MyST if that is a totally foreign term to you, but I think that's a sort of separate talk. And so this is a proceedings article from last year. It's not a PDF. It's actually a website, and this is a figure in a paper where you can explore and play with this little head. And this feels better to me than just a PDF. So yeah, the sorts of things that we enable in the SciPy Proceedings, we think about everything as web first. And so that means like we don't care about PDF formatting so much. We want it to be friendly and responsive in the web and mobile friendly. And that lets you do, all sorts of nice things. You can have these little hover references so you can cross-reference figures and see them in line. You can do the same thing with abbreviations. That also, especially for the Python world, you can also include GitHub code and issues and pull requests in a more dynamic way. And then I mean, this is like sort of basic. This feels like basic stuff for web sites and web applications like dark mode and being able to copy code. But when you're thinking about coming from a PDF, it is feeling marginally revolutionary. Cool. And then I guess also like embedding notebook outputs. And so we allow SciPy authors, if they want, instead of doing their research and then going to write a paper about it, if they want to just like take a notebook that they've curated really nicely and they've put a narrative in place and they have these interactive figures, they can just publish the notebook directly. And so this is, I don't know, this is part of what sort of Curvenote is trying to do in connecting the way that researchers work to their publishing and like making that as easy as possible. And of course, we still, of course, maybe not of course, since I talk so nastily about PDFs, but we do still produce PDFs because a lot of people still want to share in that way. There's people who just want a PDF and don't want to deal with a website. And so we make PDFs that we think look pretty nice, and we use Typist, which is another modern open source tool that's kind of a replacement for LaTeX that makes our lives easier when we're exporting PDFs, because as a company at Curvenote, we aren't LaTeX exports, and are happy to support another new modern open source tool. Yeah, and I don't know. This is like kind of this is what I like about the stuff that we do. So all of the articles that are published through Curvenote, and so that's SciPy articles, they have this underlying structured data, and this is actually what allows us to do the nice hover cross-references. Is that an article is almost like, in addition to being a nice website, it also has its data attached to it, so you can almost treat it like an API and like find all of the figures in an article or find a specific figure in an article by a label. And then just while we're talking about structured data, there's also this thing called JATS, which is a really old XML way that publishers held articles as structured data. And we still kind of like understand that as well. And so that's a connection back to the older publishing way of doing things. I don't know, I feel like that's not super relevant to this talk, so I don't know why I'm talking about it, but that's okay. This is like getting into the workflow. So we, the way that we publish research is very different than before, but we're still really inspired by the way of the like workflow of submitting articles and reviewing in an open way. And so we still do all of our reviews through GitHub. And so if someone wants to submit a paper, the way that they express interest in submitting a paper is by opening a pull request before the deadline. And now Curvenote has some GitHub actions that do a couple things. First, they give you a little status build to say if the build was successful. And then you can go visit a preview of your article. So when you first open a pull request with your content, you can immediately, after the GitHub action runs, so not immediately, but pretty quickly, go to a preview page where you'll be able to see exactly what your content looks like when it will be published. And you can also look at the PDF that'll be produced, make sure everything's working nicely, make sure all your figures look how you want. But then we also run some automated checks. And these checks include things like ensuring that authors have affiliations and there's a corresponding author, and we like recommend that people have an ORCID, which is a unique identifier for researchers, and it also checks that your citations have DOIs. So these kinds of things that, like, I don't know, these unique identifiers are very important for science and like keeping everything connected, and like, I don't know, when you cite things, keeping the things that you cite close because you can access them through the DOI, and also like keeping authors consistent. If you use the ORCID across multiple papers, but then you change your affiliation, it'll still be you because of that ORCID. Yeah, so we like all of this nice metadata, and having these checks, it's great because it's like a GitHub check that then fails, and it shows the authors what they need to fix. And so without like a person saying, oh, you should have an ORCID because of whatever, it's just like a thing that instead of being green is orange, and they're like, oh, well, if I go create an ORCID or add my ORCID, I'll turn this green. And it's like, it's a nice way to get authors to upgrade their content just totally on their own. Yep, and then so this is kind of getting into the reviews. They also happen on GitHub, totally in the open, so that yeah, people can leave a comment, they can suggest a change, and then when the author responds to that change and pushes a new commit, then the build and checks will happen again, and they'll get to see their rebuilt article with the changes they made. And after all that's done, we make DOIs for all the articles, and the proceeding site gets updated, and this is kind of what the proceeding site looks like. Nice. And we also have some other things that like just don't even, well, I don't know, like if you're thinking about like a just an old static site with PDFs on it, we now have analytics, so we can see like what, it's pretty basic now. It's like what articles, we could see like what articles get visited the most, but I think just thinking about in kind of this web first way, you can start to think about how like, okay, if you're building a website and you want to have analytics and see how users use your website, you can do the same thing with your scientific articles and like see which scientific articles are engaging and what figures people are looking at and what figures are being cross-referenced in other places. And so I think that this is a pretty cool like future possibility. And then also we kind of allow for continuous improvement, and papers can always be updated if someone finds a mistake or wants to make a change, or a late review comes in or something. They can continue to like push a new version of that paper on GitHub, and that'll trigger the GitHub actions, which will re-release the latest version to the proceedings site. Yeah, so yeah, where do we go from here? This is talking a little bit about kind of what Curvenote does and about the future, I think. And we just want to make things easier for authors and better for readers, always. Yeah, and so this is, I don't know, this isn't quite as nice a figure as on some of the other slides. But what this figure is showing is that the little, the cross-reference pop-up here, this source, this is actually coming from another website entirely. And so that is, you can think about that as like one article cross-referencing from another article. So once we have more scientific content being published in this way, then we can interlink things even nicer. And if you're writing a paper and you're like, oh, well, there was that SciPy paper 3 years ago that had a really cool figure. They're like, oh, if you go back to SciPy 2024 and see figure 1, and then that could be like a pop-up in line that just loads right there. And it just makes everything more connected and easier to explore. And then that's not just within SciPy, that's anything that uses the sort of MyST way of publishing articles. So that could be across other places, like if someone has a really cool Python package that does awesome science that they then publish a SciPy paper for, and it has like 3 cool figures in it, and then they want to make some docs for their package, they can just embed the SciPy figures in their docs, and it's like it's the same figure being reused in multiple places, rather than having to like, okay, find where that figure was made, make it again, put it here, and then if we update it in one place, it's not updated in the other place. You can actually like share content across these different domains. And I think that as we use the same like SciPy Proceedings workflow in other places, the number of domains and places you can share content among grows. And so just some examples about other things Curvenote does. This is a journal called Elemental Microscopy, and they have a very cool microscope that gets a lot of data, and they make amazing notebooks. And so they are working with us in the same way that SciPy is working with us to build a journal that's full of these interactive widgets that they have, and this is just the way they publish. This is their publication, and like this is the sort of status quo for an article, is having interactive things. We also, this is like a nice little thing to kind of be like, it's not actually that hard to publish with MyST. This is a high school we work with, and we work with a teacher at the high school who gets his students to write articles in MyST, and this works exactly the same as the SciPy Proceedings, where the students open pull requests with their articles, and so like they're learning GitHub as they do this, and learning about writing in Markdown, but they're able to do it, and over the course of the year, they get a journal published with us. And then we also work with research groups at universities, and so this is another group that has a similar workflow. It's not a journal, but it's just how they show off their work. So they publish their content to whatever journals they want, but then when they want to actually show off what they do, they tell people to come to their lab group website and explore it there. And so then all of this is built on the same sort of infrastructure and has the same structured data that underlies SciPy Proceedings. And so you can cross-reference across all of these and kind of just like grow the connected science everywhere. Yeah, I don't know. And yeah, so like just Curvenote's vision is that we want to build a future where scientific knowledge is open, modular, and reusable, and bridge the gap between how science is done today and how it's shared. And yeah, we're very happy to work with SciPy to keep on doing that. You can visit the Proceedings site at proceedings.scipy.org. There's a bunch of us on the Proceedings committee. I was asked to not point them out, but maybe I'll make them raise their hands. Yeah. So it's a team effort, and Curvenote doesn't do it all. We just do a little bit. The 2025 Proceedings, they'll be out around the end of August. We don't want authors to be so stressed coming up to the conference. But if you want to follow along, all of the PRs are in, and people are talking about them, and you're welcome to go take a look on the GitHub as well. Yeah, that's it.
All right. Well, we have plenty of time for questions, and there's actually a good number in here. So I'll try to go based on the thumbs ups ranked. So first one, are all the things that are run on the CI for pull requests also runnable locally so we can use them when developing the paper before submitting it?
Yes. Yeah, you can do all that through the Curvenote CLI, which is open source. And so you can run, so if you download the Curvenote CLI, you can do like Curvenote start, and that'll build the preview, which is the same preview that you'd see from the pull request, and you can run Curvenote check. And if you say Curvenote check SciPy, it'll hit our API to find what checks SciPy asks for, and it'll run the same SciPy checks as are run on the GitHub action.
Having computation associated with web publications is hugely exciting. Can you talk about ways to connect computation while keeping it robust to infrastructure changes, breaking publications in the future?
Yeah, I mean, I think that's definitely a problem. It's like the same sort of thing that yeah, and anything has with this, I guess. Yeah, I don't know. I think that like keeping, well, yeah, there's like the keeping the dependencies there is good, and like having a managed. I guess it's, I don't know. I don't have a good answer.
Like pinning dependencies and
yeah. I mean, there's that, and then I think there's always like the risk of whoever's hosting it is going away. But I think that like what Curvenote does is we work with open source solutions on these things and open platforms. So so you can continue to host what makes your paper work. Yeah, I don't know. That's like a terrible answer.
No, I mean, it's kind of I think probably a thing that will remain to be a point of concern, because PDFs, that always works.
Yeah,
and
totally.
it should always work,
Yeah,
right? That's
yeah.
the spec that's
I can
stable,
probably.
Yeah.
Yeah.
Is a PDF also generated with the web page and SciPy resource?
Yeah.
That's a good fallback.
But yeah, I might be able to answer
So,
in chat async better.
So sort of related, but papers. So in the academic world, papers being archival is sort of embedded into academia, right? Even though obviously software works much differently and things continue to evolve. But when you have a paper that's published, any changes to that paper are a big deal, whether it's retracted or updated. It's like it's announced very widely. So are there any concerns, or have people raised concerns about paper content just sort of changing invisibly when these are now out in the world and considered archival?
Yeah, I mean, I think that's like so much of the work that Curvenote does is like, oh, we want to do things this way, and the publishing industry does stuff this way, and like we're not gonna be able to, just like be like, okay, well, publishing industry's gone, everyone's happy here, and so I think that it's a matter of like just trying to change how people feel about research and understand that science is continually evolving and scientists get stuff wrong all the time, and that is what science is, and it seems like ridiculous that if you get something wrong in a paper and then you have to change it, that it's like such a bad thing. It's like, oh no, actually it's a good thing, like you did better. And so I think in terms of what we do, it's making it so those changes aren't invisible, and make it clear that, oh no, this is actually version 6 of the figure. and you can go back through these other versions, but like because it's version 6, that means it's like whatever 5 steps better than version 1. And so yeah, I think it becomes like a user experience problem, and it like would become easy if you like it'd be really easy to like make it so you can just push a change and it comes in silently and there's no indication that it's a different version than the version that was there originally. But I think if we make it so it's clear that it's a different version, then that's like what we want to communicate.
Yeah, I mean, I would argue that it's actually not even the publishing. It's the academia and researchers,
Sure.
who expect
totally.
this is static.
Yeah.
But as long as it's obvious,
Yeah.
that I think most people would appreciate the ability to change something that they got wrong without it being like, we need an erratum or a corrigendum or whatever the hell they're called.
Yeah.
So I think, but just making it obvious.
Yeah.
All right. Try to figure out the ones that... Okay, sort of related, maybe PDFs make some sense in science because the format is backed by a spec which is stable and for which PDF readers do a good job of supporting. The web moves a lot faster, and so something published as an HTML plus JavaScript plus CSS might look or read differently now and in 10 years. I guess it's sort of related to the computation question too, but how do we ensure stability in those published resources?
Yeah, so I feel like that's a easier question for me to answer at least, I guess, because that goes back to my slide that had the like green JSON on it, is that behind every article there's this structured data, and so that structured data, that like is the article, and so you can change the rendering on top of it, or maybe like JavaScript packages will stop being supported, but it's not like HTML that'll break. It's like just structured data that's the paper, and so you can continue to kind of evolve the front end on top of that or change the front end, but it's that like underlying data that'll stay the same.
Cool. So traditional academic papers have the anonymous, generally have anonymous reviewers, and even though some journals may or proceedings may choose to have open review, some may still prefer to keep anonymous blind reviews. Is there a way to support anonymous reviewers in a GitHub-based workflow like this for a journal that based on this technology?
I don't think so. If you want it to be on GitHub, I mean, maybe there is in some complicated way of like making forks that that reviewers have access to. I feel like though, if we were going that way, that's more like outside GitHub in a separate platform for reviewing. Sure. I think that doing it in GitHub is a way to make it open and obvious, and and that's like another like academia publishing kind of philosophy thing that's hard, and like I feel like open reviews are nice because like authors and reviewers can communicate freely and like understand where everyone's coming from and get different perspectives. But that like is, I don't know, a lot of people want to be anonymous for whatever reason. So
yeah, and some, like I said, some journals may prefer, that
exactly.
particular domain or society may prefer. Yeah.
And so then I think that's more like a separate review platform offering or something.
Is that something that you've looked, have Curvenote has?
Yeah. I mean, we've spent a lot of time going and finding all of the little pain points that people have and trying to like prototype sorts of ways that we can do different things. So that's one thing we've explored, but not done anything about.
All right, maybe some smaller questions, but when the GitHub action produces a preview page in a PR, where is that actually hosted?
It's hosted by Curvenote. So we have, I guess the content is on just like in a Google bucket, and then we host on Vercel the page that renders it.
Okay. And you may have shown this, but do you support table exports, like exporting to CSV or something like that? So instead, people having to scrape data from PDFs like in the past.
So I guess we don't like support any exports to. We don't like have a table format as a targeted export, but the table is in the structured data in whatever way. I guess it kind of depends on how you define your table. Probably the easy answer for that is no. I guess it's a little better than a PDF because you're like getting you could have a table that's defined as HTML in your JSON file, or a table that's defined as CSV that is like rendered through the same Jupyter rendering mechanism, or like a pandas tables work and render on our websites because we have the same sort of rendering abilities that a Jupyter notebook has.
Well, maybe that's a feature request because actually getting data from tables when
totally.
in a paper is very useful sometimes.
Yeah,
so.
and that's like when for like these auto-generated PDFs, tables are one of the things that is always like not great.
All Let's see if we have any final question. All right, could the technology be useful for less academic, more like blog, medium.com like articles?
Yeah, definitely. I think that when you get into that, like we really like work with scientists, and so we try to make things easy for scientists. So if you come in as just like a blogger, you'll probably find tools that are more catered for you as a blogger who just wants to get whatever you're writing online. But you can write in Markdown and use Curvenote. You can use our Curvenote CLI to push your blog post, and you can do all of that through Curvenote for free, just to a little site that is a like curve.space domain.
The last question that I see in Slack is how easy would it be to fork SciPy Proceedings and spin up another Proceedings for something else?
I think it would be. So I guess the bit there is we don't have the like self-starting stuff on the Curvenote platform. So you'd have to get in touch with us and be like, hey, we want to start a Proceedings, and then we'd have to do a tiny bit of work to like set up a site for you. But the actual submission side that's in this repository would be quite straightforward. It's basically just a few GitHub actions that you'd have to change where you're pointing it to.
All right, well, we had another last-minute question addition, so I'll go ahead. Can the papers that contain code be sent to a Jupyter Hub for execution or executed locally to experiment with code?
Yeah, so I guess, so this is for like editing the code, maybe, I guess?
Yeah, I think experiment, yeah.
Yeah. So, JupyterBook, which is also built on MyST, has like a launch in Jupyter button, and so that kind of thing just brings you to a Jupyter Hub with the code editable in it. Yeah, I think from the like SciPy Proceedings point of view, we don't have it like trivial to export the code, but it's like the like infrastructure to do it is there, and it's just like making the code cells editable basically, and whether or not we choose to do that. And so it's more of like a user experience sort of problem and thing to solve what's the right user experience rather than a technology thing, I guess.
I imagine that might also require, like, if there's data, it's not just going to be code by itself frequently. There'll be some data that might need to be brought in. And like,
totally.
Yeah.
Yeah. And so like for the microscopy journal that I was showing, we work with them to get their like Jupyter Hub set up so that when they're executing their kernels, or their articles to make the widgets workable, they have all the data that they want already on the thing on the kernel that's working. And yeah, so for something with SciPy, it's more generic, since it works for all the articles, and it would take a little work to get there.
Cool. Well, I think that was the last question I saw in Slack, so let's go ahead and thank our speaker again.